Hi there, Mr. Holcomb here with another episode of the Math Behind the Modules. This lesson, lesson 10, is an understanding in the multiplication of integers. An integer is a positive or negative number that is not a decimal or a fraction. Okay, so in groups of 4, students played on one round of the integer game in class. So I'm going to recreate an integer game for your viewing pleasure. So here's example 1. I have a random card generator here so you can see it. My first card I drew was an ace. So an ace means, let's move my recorder out of the way. Where can I put that? Okay, an ace means -1. So red cards are negative, black cards are positive, ace is 1. We're only going to use 1 through 10, no face cards. So everything is worth their face value where ace is 1. So I draw a -1. I'll draw another card, and that is a +3. Okay, now I draw another card, and it's a -8. And draw one more card, and it's a -5. Okay, so now we're done drawing, so let me go up here and maximize this. Okay, so I have -1, 3, -8, and -5. So step 1, you're supposed to copy from part A the number we got in the starred box where all the stars are. So I'm going to put -8 here 3 times. Then I'm going to bring down my -1, my 3, and my -5. So I have -1, 3, -5, and the starred -8 3 times. That was part B. Now it says use your cards from part B to answer the questions below. It says write a product that describes the 3 matching cards. Okay, well, 3 matching cards as a product would be there's 3 of them times -8. Okay, rather than using an X, I'm going to use a dot. Okay, so dot means times as well. Write an expression that represents how each of the stars changes your score. Well, what happened was if we drew a -8, it would drop at 8, plus a -8, plus a -8. Okay, that's an expression representing how each of the stars changed our score, one at a time. C says write an equation that relates these 2 expressions. So now I can take this 3 times my -8 and equals B. So part A equals part B. So 3 times -8 simply means -8 plus -8 plus -8. And it says write an integer that represents the total change to your score by the 3 star cards. So what they're saying is, what is 3 times -8? And it is -24. Now it's asking us to write an equation. So I say 3 times -8 equals -24. Okay? So this is just explaining that multiplication is just simply adding a number, the number of times we're multiplying by. So 3 times -8 means -8 added 3 times. Okay, so let's try that one more time. So now we're going to do it one more time, get a feel for it. I can minimize this, put it over, and I'm going to draw again. And I got a 1, and it's positive. Clubs and spades are positive. 8. Draw again. -9. Okay, red's negative, diamonds and hearts are negative, and then finally a +10. Okay. So now I'm going to put a 1 here, the 8 here, the -9 here, and I'm going to write a 10 every time I see a star, and that's the rest. Okay. Now it says, use your cards from Part D to answer the questions below. So now we're using the cards from Part D to answer these questions. Write a product that describes the 5 matching cards. Well, there's 5 of them. And they are 10s. So there's the product that describes these 5 cards. Write an expression that represents how each of the starred cards changes your score. It's 10. That's 10. So we added 10 every time we drew. Okay. Now it says write an equation that relates these two. Well, this is an expression, this is an expression, and they want an equation that relates the two. So the equation has an equal sign. A lot of students miss this. An expression does not have an equal sign, but it has operations. These are expressions. And an equation is an expression equal to something else, another expression. All right, so then this would be 10 plus 10 plus 10 plus 10 plus 10. Now it says write an integer that represents the total change of your score by the 5 cards. And that is going to be 5 times 10, which is 50. Okay. Jay says write an equation that relates the product and how it affects your score. So now I'm just going to say this, 5 times 10 equals 50. Kay says use the expression 5 times 4 to relate the multiplication of a positive valued card to addition. Okay, use the expression to relate the multiplication of a positive valued card to addition. So what that means is multiplying a positive integer card is repeated addition for the positive integer card, and it increases your score. So 5 times 10 equals 10 plus 10 plus 10 plus 10 plus 10, which is 50. Now it says use the expression 3 times a -5 to relate the multiplication. I'm sorry, I'm supposed to use 5 times 4 here. This is supposed to be times 4. So that means, I was right. Let's leave it 10. Sorry about that. Now it says use the expression 3 times -5 to relate the multiplication of negative value cards to addition. So 3 times -5 equals -5 plus -5 plus -5, which equals -15. And now that I'm going back here, we're just doing different examples here, so that does, I do want to say 5 times 4 here, so it's 4 5 times. And that does equal 20. Alright, next question. Now it says if all of the 4s from the playing hand on the right are discarded, so we're going to take all these and get rid of them, how will the score be affected? Model this using the product in an equation. So the score decreases by 4 3 consecutive times. So it's going to decrease a total of 12. So as an expression, as a product in an equation, we're going to take 4 and we're going to remove it 3 times. So removal is minus. So we're going to take negative 3 times 4, and that equals negative 12. What 3 matching cards could be added to those pictured to get the same change in score? Model this using a product of equation. Okay, to get the same change in score, we would add 3 negative 4s. The equation would be 3 times negative 4 equals negative 12. So what they're saying is if we only had this negative 5 and we wanted to decrease it by 12, what would we have to draw? We'd have to draw negative 4 3 times to get negative 12. Okay. C says, seeing how each play affects the score, relate the products that you use to model them. What do you conclude about multiplying integers with opposite signs? So what we should see from this is a negative 3 times 4 equals negative 12, which equals equals 3 times negative 4. So here we have negative 3 positive 4, which is negative 12. And now we have 3 and negative 4, which is also equal to negative 12. So negative 3 times 4 is equal to 3 times negative 4. So adding a value multiple times has the same effect as removing the opposite value the same number of times. Okay. So if we add a negative 4 3 times, it's the same as subtracting 4 3 times. Example 3. If the matching cards from the playing hand are on the right are discarded, how will the hand's score be affected? Model this using a product in an equation. Okay. Let me type this up, it'll be easier. I'll be right back. Okay, so removing negative 2 from the set of cards will cause the score to increase by 2. Removing all 4 of the negative 2s causes the score to increase by 2 4 consecutive times for a total increase of 8. In other words, negative 4 times a negative 2 equals positive 8. Okay, B. What 4 matching cards could be added to those pictured to get the same change in score? Model this using a product in an equation. So what 4 matching cards could be added to those pictures to get the same change in scores? Okay, so that would be an increase of 8 can come from adding 4 2s to the card shown. 4 times 2 equals 8. C. Seeing how each play affects the score, relate the products that you use to model them. What do you conclude about multiplying integers with the same sign? Okay, so seeing how each play affects the score, relate the products that you use to model them. Okay. So negative 4 times a negative 2 equals 4 positive 4 times a positive 2. So adding a value multiple times that has the same effect as removing the opposite value of the same number of times. In other words, a negative times a negative is positive. Positive times a positive is also positive. Okay, D. Using conclusions from example 2 and 3, what can we conclude about multiplying integers? Write a few examples. So here's a few. Okay, the product of 2 integers is equal to the product of their opposites. Removing 2 negative 4s is the same as adding 2 positive 4s. Adding 3 negative 5s is the same as removing 3 positive 5s. And a few examples include -4 times a -5 equals +4 times +5. -2 times a +7 equals a +2 times a -7, and so on. Okay? And that's the end of lesson 10. Hopefully the card drawing game was a little bit better than just taking notes, and hopefully you understand that adding and removing multiple times is the same as multiplication by that number of times. Now go do your drums.